Hey guys, today's video is about model evaluation. In the last video, we introduced F1 score, so today we are going to talk about F-beta score, which is the general version of F1 score. Just to recap, F1 score is the harmonic mean of the precision and recall, and it's popular because it provides a single measure to evaluate the performance of model. A single number is important, since when we have thousands of models, programming algorithm can easily find out the best one. Further, we want to maximize F1 score because we also want to maximize precision and recall, and the formula for F1 score is 2 times precision times recall divided by precision plus recall. However, the harmonic mean implies recall and precision are equally important in F1 score. If you remember, we've discussed the situation when we care about one measure more, such as access control system and random advertisements. In fact, F-beta score can solve this problem by making beta a free parameter. Here is the formula for F-beta score: 1 plus beta squared times precision times recall divided by beta squared times precision plus recall. F-beta score introduces a new parameter, beta, which is a non-negative number that can be defined by the user. If we look at the F-score or F1 score, we'll find the beta is fixed to be 1. Don't worry if you don't understand, I'll prove this later. Since beta is a free parameter, F-beta is the weighted mean of precision and recall, while F-score is the harmonic mean. After knowing the formula, you might wonder how to select the appropriate beta. Actually, this selection depends on which measure do you care about more, precision or recall. When beta is 0, we consider precision only, and when beta is infinity, we consider recall only. Let's do a little bit mathematical proof. If we replace beta with 0, the formula is like this. In the numerator, 1 plus 0 is 1, so we can ignore 1. In the denominator, 0 times precision is still 0, so we cross out this bracket. As you can see, the formula becomes precision times recall divided by recall. Intuitively, we cross out the variable that appears in both the numerator and the denominator, which is recall. Therefore, when beta is 0, F-beta score is just the precision. Alright, what if beta is infinity? Instead of directly replacing beta with infinity, we first divide the whole formula by beta squared, and the formula becomes something like this. Then, we try to replace beta with infinity. From high school math, we know the limit of 1 over beta squared is 0 as beta approaches infinity. If you don't know what I'm talking about, just think about it this way. 1 over 10 is 0.1. 1 over 1,000 is 0.001. So when the denominator increases, the resulting number becomes smaller and smaller. What if the denominator becomes infinity, only infinity squared? The resulting number will be super close to 0, that we can just think about this number as 0. Thus, we now replace 1 over beta squared with 0. In the numerator, we cross out 0, and in the denominator, we cross out 0 times recall, because 0 times recall is just 0. Now the formula becomes precision times recall divided by the precision. Obviously, we can cross out the precision in both the numerator and the denominator. Voila! When beta is infinity, F-beta score is essentially the recall. Next, when beta is 1, F-beta score is the F1 score. This proof is really simple. We replace beta with 1 and get the formula of F1 score. And the 1 in F1 score is just replacing beta in F-beta score with 1. Now we know what happens to F-beta score when beta changes, but how do we choose beta exactly? In fact, the cutting point is 1 because F1 is the harmonic mean. We choose beta between 0 to 1 when we care more about precision, and we select beta larger than 1 when we care more about recall. Can you think of a time when we care about precision more or recall more? As a reminder, I put the formulas for precision and recall below them. The difference between them is in the denominator. Precision contains Fp, recall contains Fn. Consequently, we choose beta between 0 to 1 when we want to minimize false positives, such as cancer diagnosis. Further, we choose beta larger than 1 when we want to minimize false negatives, such as access control system, and this is how we select the appropriate beta. Congratulations, we've finished the first section, Confusion Matrix. We'll discuss model validation next time. Thank you for watching my video and see you next time.